Welcome to this UniLogic tutorial. UniLogic is the complete application development environment for our Unitronics UniStream control platform.
My name is Alex, and today's tutorial is about the Message Composer. This tutorial will cover a brief overview, communication options, open protocol terminology, ASCII and hex characters, setting up messages within the Message Composer window, ladder logic for TX and RX, and a demo program to both send and receive messages. The Message Composer is used to both send and receive open protocol messages using the UniStream. Open protocol is a protocol with a known message format. The Message Composer is a powerful tool that allows our UniStream PLC to integrate with an open protocol for communication with a third-party device. Devices such as barcode scanners, ASCII printers, sensors, or other devices that use a proprietary protocol can then communicate easily with our hardware. Tag information such as analog values, temperature readings, numeric set points, product information, or I/O statuses can then be received or transmitted using the Message Composer. The Message Composer can be utilized with many of the COM ports on the UniStream, such as RS-485, Ethernet, USB or serial, or RS-232. The UniLogic Message Composer works with a combination of ASCII and hex characters. These characters can be used and defined by different tags within the logic. Different devices may use certain ASCII or hex characters to indicate the start or end of a message. A checksum or a CRC can also be utilized for each device, which adds a generated code to verify message integrity. Checksums can also be helpful to reduce any electrical noise or irrelevant data that is not accepted by the PLC. Computers, PLCs, and devices only work with numeric information. ASCII characters are an alphanumeric representation of decimal or hex values. Displayed on this chart are the most commonly used 127 characters, although the full ASCII table can display up to 255 characters. It is important to know that ASCII is case sensitive, with upper and lowercase letters being represented by different values. For example, a capital A is represented by decimal 65 or hex 41, while a lowercase a is represented by decimal 97 or hex 61. Also important are the first 32 ASCII characters. These are the control characters that are not visually displayed, but are used to indicate any start of text, end of text, or other information for peripheral devices. Next, we can look into how we set up the Message Composer within UniLogic. Within UniLogic, the Message Composer can be found within the Solution Explorer on the left. Under Message Composer, then select CPU Protocol Messages, and selecting Add a New Device will create a new configuration. Any start of text and end of text characters, as well as a checksum, can then be defined in the Properties window on the right side of each device. Multiple messages can be set up for each device by selecting the Add New Message icon in the center of the screen. The messages can then be created and defined by selecting the blue text link under each message. Once the message is selected, this screen then allows messages to be defined using a drag and drop interface with different message elements. Elements such as fixed text or hex characters can be added to define static variables. Additional elements include binary text variables, list of text, numbers, or raw data for ASCII strings. These elements allow any tag information to be added within the message. There are also two options within the Properties window that can be modified. First is the message name, which can be defined from the default value of message 1. And second, and most important, is if the message will be scanned. This checkbox will allow the controller to scan for this message and place any received data directly into the selected tags. Returning to the device window then displays a preview of each created message. Next, the messages can be defined for this tutorial. These are the two messages that will be configured for this tutorial. The first is a message that will be sent to a PC program to define a set point using a numeric tag. The device requires a start of text and end of text character in order for this to be accepted. The second is a message that will be received by the UniStream. This message will turn an output on and off based upon if an on or off command is received. Static text is used to indicate which output is being referenced. This command also uses additional hex characters such as a carriage return and a line feed. Though only a simple example, this shows how messages may be formatted for use with different devices. Longer and more complex messages using many different variables can also be defined within the message composer. In order to test these messages, a PC-based utility program, Hercules, will be used to both receive messages from the UniStream and send them back. The PC and the UniStream will be connected using a serial connection. Next, we can start building the project in UniLogic. Before the messages are set up, a COM channel needs to be defined. For a serial connection, the panel's USB port will be utilized. This can be found under PLC Communications, Physical, and then Panel USB port. In order to use the port for communications, the Enable USB for Serial Device box must be selected. It is also important to configure the UniStream's COM port to match the connected device's hardware settings in order to properly communicate. These settings will match the PC program Hercules using a baud rate of 11/5200, 8 data bits, no parity, and 1 stop bit. Once the COM port is added, then the messages can be configured. Navigate to the Message Composer within the Solution Explorer on the left. Then CPU Protocol Messages. And a new device can then be added for our serial utility program, Hercules. On the right, our device name can then be changed to Hercules. And although the utility program Hercules does not require any start or end of text, they can be added to demonstrate this ability. A start of text character, hex 02, can be added for the start of text and for the end of text. An end of text character, hex 03, will be added to indicate the end of text. This example will not use a checksum, though one could be added within the Properties window if required by the third-party device. There are various checksum methods available which are device-specific. After the device properties are defined, each individual message can then be added and configured. I can select Add New Message for our first message. In this first message, what we can do is configure a tag value to be sent referencing an integer value. This tag value can represent a set point to send to another device. As shown in the example before, the receiving device's protocol could use static text to indicate what the number represents. Adding fixed text in the beginning of the message for SP could be used to indicate that the number is specifically for a set point. The fixed text element can then be added to the body of the message for exactly this purpose. Next, a number variable can be added to the body of the message for the set point's value. Within the number variables properties window, there are a few options. Importantly, the variable must be linked to a data tag, which for this example will be a 16-bit integer. This has been previously created exactly for this example. There are also options to enter a decimal point, and if necessary, the displayed format can also be changed. This completes the first message's composition. Next, the second message can be then set up to receive a bit status to operate an output, as previously described. First, ensure that the scanned checkbox is selected in the Properties window in the bottom right. This will allow the controller to populate the tags within the message with any received data. Next, static text can be used to define which output is being referenced, if, for example, you are using multiple outputs. I can add a fixed text element and add O1, which could represent output 1. Next, a binary text element can then be added. This element can be directly linked to an output within the controller if desired. This will be also linked to a bit that has been previously created for this purpose. Then, text can be defined for the on-off states of this bit. When each message is received, the text will define how this specific bit tag operates. So when it receives the static text off, the bit status will change to off, and when it receives on, it will turn on. This message will also use additional control characters, such as the character turn and line feed, which can be added with the control character element. Once that's completed, the second message is now configured. That is all that's required for both of these simple messages. The start of text and end of text characters will automatically be added when the message is compiled within the logic. Next, the ladder can be set up in order to send and receive messages over a COM port. Before working with the function blocks, it is important to know that when working with the message composer, there is a process to both send and receive messages. All information is sent and received through an intermediate buffer tag. When sending a message, it is first converted into a buffer, and then it can be sent using the transmit or TX function block. When receiving a message using the RX function block, it is first converted into a buffer, and then that message can be parsed through the message composer. Navigating back to the ladder, each of the required functions can be found within respective toolbox folders. The TX and RX functions can be found in either of the COM menus. Serial for any USB 45 or RS-232 COM ports, or the COM TCP/IP if using an Ethernet port for communications. The build and parse message functions can also be found in the COM protocol third-party menu. Next, the ladder can be set up to send and receive messages. First, the ladder can be set up to send a message to the PC program. A button previously set up on the HMI display can trigger this command. A direct contact can be used to trigger the logic and link to a button on the HMI. Next, the message must be built using the message composer and sent to a buffer tag. The build message function block can be found in the COM protocol third-party menu. First, it requires which message will be built. This can be selected by selecting CPU protocols, then selecting the device name Hercules, and then the specific message, message 1, which was our message to send. The function will then compile this message and send it to a desired buffer type tag. This is output B. We have previously created buffer tags for this purpose. This one has been named TXBuffer. Please ensure that the buffer is large enough to contain your entire message, such as any start of text or end of text characters. And the function will also output the message length in bytes, which will be stored into a tag called TX message length. These two outputs will then be directly used to send the message using the TX function block. Next, that TX block can be selected from the COM serial menu. It requires which COM port will be used to send the message. This will be the panel's USB port, which was previously configured. Next, the buffer source containing the message is selected. Then the number of bytes to send is selected. These are the exact same tags from the previous output of the build message function block. Last, a reset coil will be placed to reset the send message bit so that the operation only occurs once each time the button is pressed. This finishes the logic required in order to send a message. Next, the logic to receive a message can be configured. This process will be similar to the send, only it will be in reverse. First, the receive block, RX, needs to be placed from the COM serial menu. First, the communication channel that will be receiving the message must be selected. This will also be the panel's USB port. Next, a buffer tag is selected to store the incoming information. This will be our RX buffer, and again ensure that the tag is large enough to contain all the required information, such as any start of text, end of text, or CRC. Next is the written data length of the message in bytes, which will be stored into a numeric register. And last, there is a data arrived bit, which goes high for one scan when any message arrives. Once the incoming message is placed within the RX buffer, it can then be parsed or compared and applied to the list of messages that are already created. The message will only need to be parsed once when it is received. Therefore, the data arrive bit can trigger this function using a direct contact. So this can be set up in the next net. The parse message function block can then be added from the COM protocol third-party menu. First, the message buffer to be parsed is selected. This will be the RX buffer from the COM RX block. An offset can be added if required. For this tutorial, it will remain at 0 for the start of the message. Next is the data length to parse in bytes, which can be linked to the received data length tag from the COM RX block. And finally is the required device. This will be the CPU protocols device, which we named Hercules. And lastly, this function block will output a parsed message index. This will indicate if the received message matches any of the previously configured messages for the selected device. This finishes the logic required to receive and parse a message. Next, both the send and receive capabilities will be tested using a VNC viewer and Hercules running on a PC. On the left is the VNC viewer showing the HMI of the UniStream 7 panel for this tutorial. And on the right is the PC utility program, Hercules. It is important to note that the serial port settings within Hercules on the right side of the screen have all been set up to match the serial port settings that were configured within UniLogic. First, to demonstrate the send command, we can operate that first on the UniStream panel. A value can be entered on the HMI. For example, I can enter the numbers 1, 2, 3, 4. And then pressing the send button on the HMI should send the complete message. We can then see within Hercules that the message was successfully received. The numbers in gray are the start of text and end of text characters in hex, with the rest of the message, including the static text and numeric variable, appearing in black. Now we can demonstrate the UniStream's ability to receive messages. The hex and ASCII message can be configured and typed into Hercules, which was set up previously. The message must be formatted exactly how it was set up in UniLogic for it to be completely accepted. For this demonstration, I will turn the bit on the HMI screen representing output 1 on, sending the first message with the ASCII text set to on. We can then see on the HMI that that bit was then turned on. And to turn it off, I'll pretty much send the exact same message, only now if you can see in the bottom of Hercules, the ASCII text has been changed to off. And the output turns off. It is again important to note that the ASCII characters are case sensitive, so they would have to be typed in correctly. For example, if this was modified to on with a capital O and a capital N and then sent, although we can see Hercules sent the message, the output does not turn to on. Sending the original message with a capital O and lowercase n, the message is then accepted. The last thing to point out are some tools within UniLogic that may be helpful for general troubleshooting. Within the global window, the COM port struct has a variety of tags that can be used for troubleshooting or monitoring purposes. They are located within the specific COM port, and in this example is the panel USB port struct. This struct has success and fail bits that will turn on respectively when a message is sent. There are also status messages, which indicates if the process has no errors, is started, in progress, or if there's any other errors. And a counter is also available for both the TX and RX packet counter for each time a message is sent or received. This concludes the tutorial about the message composer within UniLogic. You can find more information and example applications on our website. Thank you for watching this tutorial. We hope you found the information helpful.